Today we're going to look at graphing linear inequalities. A linear inequality is defined as a linear expression with two variables and one of our signs, less than, greater than, less than or equal to, or greater than or equal to. So instead of an equal sign, like in our Ignite, we have one of those inequality signs. So there are four graphs of linear inequalities. The first one we're going to start with is less than. So I'm going to look at what the graph of y less than 2x minus 3 looks like. So the first thing we're going to do is graph points just like we would do for a line. So I'm going to start at -3 and then go up to over 1, up to over 1, up to over 1, and so on. And I like for these to fill most of the graph. It's just easier to connect them. Then you're going to decide if your line is dashed or solid. So this is similar to having an open circle and a closed circle. So dashed is for less than or greater than, solid's less than or equal to, greater than or equal to. So this line would be a dashed line. So I'm going to connect those dots with a dashed line. So there's my line. And now I just need to do the shading part. That's step number 3. And we're going to do that. So shade by testing a point. Okay? And the point that we're going to test is 0, 0. It's a very easy point to test. The only time we would not be able to use that is if I had a point on my line be at 0, 0, but here, since we're not on 0, 0, I can use that to test. So all I'm going to do is plug in 0 for x and 0 for y. So I would have 0 less than 2 times 0 minus 3. So 0 less than 2 times 0 is 0. Minus 3, that gives me 0 is less than -3. Is that true? That's what you want to ask yourself. Is that true? Is 0 less than -3? If it's not true, which it's not, it means 0, 0 is not a solution. So if 0, 0 is right here, I split this up into two regions. So I have the top region up here, and I have the bottom region. So I'm shading one of those two. Because 0, 0 is in the top region, and it was not a solution, that means I need to shade the other region down here. And that is my solution. If you want to get into the habit of putting an R in your region, that would be good. We'll get there in 6.5, but just keep in mind that's coming. All right, for the next one, let's look at y greater than 2x minus 3. So again, following those same steps, graph points. So I start at -3, up to over 1. And I can also go down 2 over 1. Then you're going to decide if your line is dashed or shaded. This one will be dashed because it's not or equal to. It would be an open circle on our number line, so it would be a dashed line. So now I have my two regions, and I'm going to test the point 0, 0. So again, plugging it in for x and y. So I have 0 greater than 2 times 0 minus 3. 0 greater than 0 minus 3. So 0 is greater than negative 3. That is true. So that means 0, 0 is a solution. So I would shade the region that contains that point. Okay? So take a second, if you're stuck, look at the differences between these two. I'm also going to put that R up there. The next one we'll look at is y less than or equal to the line. So again, start with plotting those same points since it's the same line. Okay, so we did the points already. Now we need to decide if it's dashed or shaded. Or sorry, dashed or a solid. Okay, so because this is a less than or equal to, that would be on our number line a filled in circle. So that's going to be a solid line. Okay. So the final thing is just testing that point. So if I plug in 0, 0, I get 0 is less than negative 3, which is not true. So I'm going to shade the other region and then put my R in that region. The fourth one is greater than or equal to. So I start with those same points. And again, this is an or equal to sign, so that is going to be a solid line across my graph. Test the point 0, 0, and I get 0 is greater than or equal to 2 times 0 minus 3. 0 is greater than or equal to negative 3, which is true. So I shade the region with my test point and put an R. So those are our 4 different types of graphs, and you can see the differences, whether it has dashed lines or solid lines, and then also look at how the shading is the same or different between the different graphs. So our goal is to find the region to shade. Oops. Okay. So we're always going to graph these like we would a regular line at first. So I'm going to start at negative 7 for this one and go up 3 over 1. Okay, this is a y is less than, so it's going to be a dashed line because it doesn't have the or equal to. And then I'm going to test 0, 0. So I have 0 is less than 3 times 0 minus 7. Is 0 less than negative 7? No, so we're going to shade the other side of the line and put an R. Now my next couple questions, it says, is the point 4, 5 a solution to the system? So you have two options. You can either plug in the point or check your graph. So if I plot point 4, 5, I'm going 1, 2, 3, 4, 1, 2, 3, 4, 5. Now that is on my line. Because that's a dashed line, I'm not including any points on my line. So this would not be a solution. I'll say no. the point is on the line, which is dashed. And the reason we don't include those points is because if I were to plug this in, I would have 5 is less than 3 times 4 minus 7. So I would get 5 is less than 12 minus 7. 5 is less than 5, which is not true. 5 is not less than 5. 5 is equal to 5. So if I had a less than or equal to, it would be a solution. But because I'm only strictly talking about less than values, that would not be a solution. So the next point, negative 5, 2. Negative 5, 2 would be up there, which is not in my shaded region. The point is not in the shaded region. Again, you can also just plug it in and talk about the inequality if you're more comfortable with that. So you could plug in your point 2 less than 3 times negative 5 minus 7, and that would give you 2 is less than negative 22, which is false. So you could also talk about that inequality not being true. Either one. The next one we'll have to solve to get y by itself. So I'm going to subtract x, and I get negative 2y greater than or equal to negative x minus 6. Divide by negative 2, everything. I get y is less than or equal to, I divided by a negative, so I need to switch my sign. 1/2 x plus 3. So I'm going to graph that, start up at 3, go up 1 over 2, down 1 over 2. And it is an or equal to, so that would be a solid line. Then I test my point 0, 0. You can test it in either spot. It doesn't matter. I'm going to use this one though. So I have 0 less than or equal to 1/2 times 0 plus 3. This cancels. Is 0 less than or equal to 3? That is correct. So I'm going to shade this whole region below and then write my R to show that that's my region. Okay. Now my questions, again, is the 0.45 a solution to the system? Or solution, this should say, to the inequality. Same thing here. So I'm going to check my 0.45. So again, the point is on the line, but the line is solid, which means I'm including those points. So I'm going to say yes. The point is on the line, which is solid. Okay? So if you prefer to plug that in and check what that means, I would say 5 less than or equal to 1/2 times 4 plus 3. 5 is less than or equal to 2 plus 3. 5 is less than or equal to 5. So because I have that or equal to, that is a true inequality. And then last one is the 0.02 a solution. So if we look at my graph 0, 2, that falls in the shaded region below the line. So I'd say yes, the point is in the shaded region. Okay? Go ahead and review any of that if you need to. Otherwise, you can move on to your you try nows. So this you try now, y is greater than 3, that's a horizontal line. Remember, y equals a number is a horizontal line, and x equals a number is a vertical line. So I'm going to have a horizontal dashed line at 3 because it's just y is greater than, not greater than or equal to. And then I'm going to test that value. So I'm testing the point 0, 0, but I'm only concerned about plugging in the y value. So I would say 0 greater than 3. No. So I'm going to shade the other side, and that is my region. The last one I need to solve for y, so I'm going to just divide by 3. So I have y is less than or equal to 3 minus 1/3 x. And make sure this is my y-intercept here. This is my slope with x. So just be careful when you graph. So I'm going to start up at 3 and then go down 1 over 3, down 1 over 3, down 1 over 3. Same thing in the opposite direction. And that would be a solid line. I'll test the point 0, 0. So I have 0 less than or equal to 3 minus 1/3 times 0. That cancels. Is 0 less than or equal to 3? Yes, it is. So I shade down here. And then put the R. And that's it.